All right, this problem is asking us to find solutions of the equation 4 cosine squared gamma plus 2 cosine gamma equals 0 in the interval from gamma equals 0, potentially including 0, to 2 pi, and we're not going to include 2 pi. So if we first just start out with some simple algebraic manipulation of this, we're going to end up with 4 cosine squared gamma equals negative 2 cosine gamma by subtracting 2 cosine gamma from each side. Now we're going to do something that's a little bit tricky. We're going to divide by 4 cosine gamma, which we can't do if 4 cosine gamma equals 0. So we want to come back and look at, can 4 cosine gamma be 0? We'll come back and look at that later. But for now, divide by 4 cosine gamma, then cosine gamma equals negative 1/2. So gamma is the inverse cosine or arc cosine of negative 1/2. Come back and we ask ourselves, if 4 cosine gamma is 0, does that satisfy the equation? That's really our question here. If it is, then we also need to include these possible solutions. So divide both sides by 4, cosine gamma equals 0. Well, that's good enough. We can go ahead and substitute that in. If cosine gamma equals 0, then cosine squared gamma equals 0 times 4, still 0. Cosine gamma equals 0 times 2, still 0. 0 plus 0 equals 0. So yes, this is a viable solution here if cosine gamma equals 0. So we want to include that. So we have cosine gamma equals negative 1/2 or cosine gamma equals 0. Basically, if you're looking at your unit circle, we're asking for what angles intersect the unit circle with an x coordinate of either 0 or negative 1/2. So draw our unit circle. That's this here in blue. We draw some lines at x equals 0 and x equals negative 1/2, and we look at where they intersect. And we can see they're going to intersect at pi over 2. This angle here, which we might not, I mean, you might know it off the top of your head that that's 2 pi over 3, but in case you don't, we'll talk for a second about how to get that. It's 4 pi over 3 and 3 pi over 2. Again, the pi over 2, 3 pi over 2, pretty easy. If you were to plug this arc cosine of negative 1/2 into your calculator, it'll tell you that it's 2 pi over 3. So that gives you this one. Just looking at it down here, we can see that it's clearly, the negative version, negative 2 pi over 3. But since we want it between 0 and 2 pi, we're going to subtract that from 2 pi. So 2 pi minus 2 pi over 3 gives us 4 pi over 3. So these are our potential angles here for gamma: pi over 2, 2 pi over 3, 4 pi over 3, and 3 pi over 2. And if you were to plug all 4 of those back into, or substitute rather, all 4 of those back into this equation, you'll find that any of the 4 of them will give you will make that equation true. So yeah, there's your solution set. Hope that helps you. Thanks.